Everyone can hear me now? Great. Where were we? We were talking about the AWS booth and whiteboarding and trading ideas for how to build better services together. And I was saying that that's been a really great experience for me. And even in putting together this presentation, I've had the opportunity to work with Jeff from MapBox, who you'll get to meet later. And it was the same kind of thing. It was, as we were building this presentation, I got to learn a lot about their use case, how they were leveraging AWS services, how they were using CloudFront to improve the experience for their customers. And we even thought about ways that we could leverage some newer, interesting AWS features, and we were kind of building products together. So it's been quite a lot of fun, and I wanted to start by saying thanks to all of you guys for coming. Thanks for cause a lot of rebuffering events, then your customers aren't going to come back to you again, and they're not going to be very happy with the experience you provided. So the question, how do you know what kind of experience you're providing for your customers? And more importantly, perhaps, is how do you figure out what kind of actions you can take to improve the experience for your customers and get more from your CDNs? In order to answer those questions, we first have to start by understanding your customer. What's important to them? Where are they coming from? Thereafter, we can start defining some measurement methodologies and figure out what kind of tests we can put out into the wild to understand what's happening with your viewer experience. And finally, analyzing the data that we get back allows you to zero in on root cause and understand which specific parts of your system may be contributing to positive or negative viewer experiences. At the end of this presentation, Jeff from MapBox is going to come up here and he's going to basically show you how all these concepts can be put into action. And he's got a couple of real-world cases and examples that MapBox used to improve their own customer experience with AWS services and CloudFront. As I said, before we know what to measure, we have to understand what's important to our customers. Customers watching video apps on mobile devices may have very different expectations than customers of e-commerce websites that expect very fast page loads. And as you think through what's really important to your customers, you should be trying to identify 2 or 3 key measurements that, oh boy, we're on the wrong slide. Sorry, guys. 2 or 3 key measurements that truly represent the customer experience. I like to think of those 2 or 3 key measurements as customer vital signs, right? These are the things that indicate whether or not your service is healthy and your customers are getting a great experience. And I think about those metrics as something separate and distinct from all of the hundreds or thousands of other bits of telemetry and data that you're collecting about your service. I think of those more as diagnostic measurements. Now, diagnostic measurements are absolutely critical to operating your service. Ultimately, diagnostic measurements are what you'll use to get to the root cause and understand why your viewers are seeing the performance that they're seeing. As an example of some customer vital signs metrics or customer experience metrics, I've got 2 clear cases. One is an availability measurement. Now this applies equally to all services and all customers. All of your customers want to get to your content. And if they can't get to your content, it doesn't really matter how fast or responsive your servers are, you're not able to deliver it to them. So the first key vital sign metric that all of our groups use is some sort of availability metric. Now, one of the tricks with availability is it can be difficult to measure an event that didn't happen. But as it turns out, customer requests tend to follow pretty standard patterns. This is an example of a customer's distribution through CloudFront over the course of a little more than 5 days. And if you look at that graph, you can see a very distinct pattern. During the weekdays, there's actually 2 peaks that occur, one at the lunchtime hour, one at the evening hour. And then during weekday days, we tend to see just one larger peak in the evening. If we're watching this graph closely, as we should be, if anything weird happens, if that pattern changes in some way, that may indicate a problem with the service. This vital sign metric is telling us that something may be up. There's some set of customers that aren't able to get to our service on the Saturday day here. Another example of a customer vital sign metric would be download latency. Now, in actual practice, I wouldn't choose this as a metric. I think it's too generic. I don't think it maps close enough to what customers really care about. But it serves our purpose and it covers all scenarios. A better metric would be to say, hey, my customers are streaming video. And I want to make sure that when they start playing a video, they don't get any interruptions at all. And a really good customer experience metric would be to track the number of video interruptions they're seeing and monitor that over time. If you see any drop-offs or spikes in that measurement, that could be a clear indicator that something's going on with your service and you need to dig in. Once you've established your 2 or 3 key customer measurement metrics, now you have to figure out how to collect that data from your customer, and there's some complexity in that. If we break it down, there really are 3 high-level ways that you can collect this customer measurement data. One is you can collect metrics and measurement from all of your servers. This could be everything from server access logs to the telemetry that's coming from the hardware itself. You can put external monitoring agents out on various parts on the internet, make requests back into your infrastructure and capture those measurements. Or you can use real user measurements and grab telemetry directly off of client devices and see exactly what customers are seeing. We can rate these 3 methodologies along 3 dimensions. One, how accurately does this measurement methodology represent what your customers are experiencing? How easy is it to get these measurements tools set up and configured? And finally, what kind of diagnostic data do these measurement methodologies yield? When we see a problem, do we have enough data to actually know exactly what's going wrong? So as I mentioned, server-side latency is really the server coming off of the service itself. These are access logs, CPU measurement. One thing that I call out that I think is particularly useful that we pay a lot of attention to is first byte latency. First byte latency is a timer that starts the minute we see a request and ends the moment we send that request out the door. It lets us see how performant our servers and everything behind our servers are doing, but it doesn't include any of the network latency. So it's a great way to get an isolated view of what's happening on the service. However, it doesn't do a great job of showing you exactly what the customers are experiencing. It tells you what the servers are experiencing. That can be a very different thing from what your viewers are seeing. As it happens, it's relatively easy to get these set up. I'm sure every one of you has server-side monitoring and measurement infrastructure for the services you're operating. And it's absolutely critical. This data is super critical for actually getting to root cause to any issues you may be facing. So I give it an A on that dimension. External monitoring involves putting robots on various parts around the internet and making requests as if you were a user back into your web service infrastructure. This might be software that's provided to you that's actually custom software that can get very detailed diagnostic information about each component of the request, or it may be actual real browsers like Internet Explorer or Firefox with some automation wrapped around it. Oftentimes, these solutions are running in anywhere from 30 to 140 different locations around the internet. And the idea there is the more locations you can get, the more likely you are to get a view from what your customers are seeing. However, I want to drill in for a moment and talk about how effective external measurement is in actually representing what customers are seeing. So the performance that customers see is actually driven largely by the overall usage of all other customers. And what I mean by that is most of the infrastructure you're using to serve content is leveraging some flavor of caching that is often kept hotter or colder depending on what kind of usage those services are seeing. And just as a really oversimplified example, we've got a web client that's making a request to a web content. The very, very first request is going to make a DNS lookup and translate video.amazon.com into its network routable IP address. It might seem silly to list this, but actually a cache miss on DNS can be somewhat costly. You can see it could be up to 100 milliseconds, which isn't insignificant. Following our DNS request, we make our TCP connection and eventually make our web request to our infrastructure for our content. If we're using a CDN, and this is the first request that CDN has seen, in all likelihood, that object won't be in cache. It'll be a cache miss. We have to go all the way back to the origin to fetch that content forward. And that's going to incur some extra time penalty for that particular user. However, our second request, the one that follows on, does its DNS lookup. It's very quick, almost instantaneous in some cases. We make our request for the content. We get sent to our CloudFront edge location, and our cache is hot. We're able to serve the request right from there and save a bunch of time. So performance depends on what other users are doing. We need hot caches in order to deliver the best performance in a lot of cases. Performance also depends on location. So in between our web client and our content sits a lot of internet network with varying degrees of latency, and latency drives performance. So users on the West Coast trying to access West Coast content are going to get a much faster experience than users on the East Coast trying to access content on the West Coast, right? And in actuality, these factors all conspire with one another to create the end result, that performance experience that your customers are seeing. And it's difficult to simulate that with external monitoring, right? If you think about it, you need to have external monitors in all of the networks that your customers are sitting in, and they need to make requests at intervals that mirror as closely as possible what your customers are actually doing. Another thing to consider when looking at external monitoring agents is really understanding where that measurement's coming from. And there's something we call a backbone measurement problem that sometimes occurs with some external monitoring agents. And that is, these monitoring agents are running in data centers in a lot of cases. In some cases, they may be running in the same data center or next door to data centers that are running your own service infrastructure. And when that happens, these external monitoring agents can see really great performance. The trouble is, your customers aren't making internet requests from data centers, right? They're connecting from their home, which connects into an ISP, which eventually gets into the data center. So the latencies you see from a backbone measurement are going to be quite a bit different from the measurements you take from the viewer networks. So for that reason, external monitoring is better than service-side monitoring in terms of giving you a sense for what the customer experience is. Still not perfect. Still pretty easy to set up. There's a lot of tools that make it easy to get up and running and have a test running on many nodes around the world, and even aggregating that data for you. And in a lot of cases, external monitors can do a good job of providing you with some diagnostic data or even diagnostic tools that can break down measurement information for the request, so you can see your DNS response time versus the TCP connect time. It can be helpful when you're trying to diagnose or get to root cause on a specific customer impacting issue. Finally, real user monitoring. So real user monitoring works by instrumenting the client itself, the thing that your customers are using to connect to your service. If it's a website, this means instrumenting the browser. If it's a video player, a lot of video players actually surface really rich telemetry information about what's going on. All of that data gets posted back up to your server and aggregated for your analysis. We don't have to worry about making sure we're selecting monitoring agents that map to where our users are, because the data is coming from our users. And the usage characteristics are driven by real user behavior. So we don't have to worry about trying to make sure the caches are representative, or we're trying to simulate user request volumes. It's all baked in. Initial versions of real user measurement work something like this. This is an example I put together using jQuery. In all cases, it's often for web clients takes the form of some sort of client-side JavaScript. This web beacon is embedded in your web page. And you create a request on the client in that JavaScript back to your service infrastructure. And that request is wrapped. You take a start time before you make the request and record an end time after you've finished the request. Now, this is a pretty common method for doing real user measurement, or was. Some of the problems you have to be aware of, you'll note that we're wrapping the entire request. We don't get a breakdown, and there's no way to know if something is slow. Was it due to DNS? Was it due to a slow connect time? Was there something else? Or even different events in the browser competing for time for the client-side processing can have some effect on your measurement. Something you should be aware of. Still, in aggregate, this gives you very, very good data, very good insight into what kind of experience your customers are seeing. So for that, I give the customer experience metric an A. Ease of setup, it tends to be more difficult. I mean, as you see, you have to find a way to instrument and put a web beacon on your own website, and have to find a way to get that data back to your own server side. Now, there are some tools out there that make the aggregation and collection easier, but you'll still need to inject this client-side measurement code into your web page one way or another. Same goes for web video clients. A lot of times, they have good telemetry, but it needs to be hooked together and somehow put back into some aggregation system in your own network. So almost all the major modern browsers in the W3C have implemented a new technology called Navigation Timing API. And its sole purpose is to address some of the downsides that I discussed in that web real user measurement 1.0 system. With Navigation Timing API, you get really accurate and detailed timing information for the web request. So you don't have to worry about other JavaScript processes interrupting in the middle of your timing event and inflating your time. And you can separate out your DNS response time from your TCP connect time and your response. So you get really rich diagnostic information. So real user measurement with navigation timing APIs still has an A on customer experience, but now we get a lot of really rich diagnostic information to pair with that, so we can get right down to brass tacks and understand what's going on with our service. So in summation, when it comes to selecting a measurement methodology, if at all possible, I would highly recommend you get your customer experience metrics from a real user measurement system. It's not to say that external monitoring doesn't have its place. I think that can also be pretty valid, but if you have the choice, look for real user monitoring. Now that we've got a measurement methodology, let's take a deeper look at the test itself. So I think this stuff is actually really cool. It's amazing how detailed of information and how much diagnostic information you can surface in your real user testing just by changing things like the object size that you're requesting, or by using various different cache busting or connection busting techniques to really isolate exactly what's going on in your client's browsers. As an example, it's possible to evaluate how well your CDN how good a job your CDN is doing at selecting an edge location for you. If you're using a CDN, you know lower latency is better. So the closer we can get the content, the user, the better we're doing. And if we look at the connect time between the client and the edge location, we can evaluate how well that CDN is doing. If we're seeing a 10 millisecond response time or connect time, we know that the CDN is actually doing a pretty good job of routing that user to an edge location, and that edge location is pretty closely located. If we're seeing 100 millisecond or higher times, that may indicate that the CDN provider is not, the selection algorithm or the routing algorithm for that specific user may not be working ideally, or perhaps that CDN provider doesn't actually have an edge location that's closely located to that customer, right? All that information can be inferred from just connect time. You can also get a sense for the performance of those cache servers by looking at the first byte latency of hits from the client perspective. So you know from the time I've issued a request to the time I see the first part of the response, that's network latency plus some of that server-side time. Using larger objects and looking at last byte latency and measuring the total time it takes to download a file, you can get a sense for the quality of the network between the client and the edge location. If a user is experiencing network congestion and packet loss, that's going to extend out the time it takes to download an object. And LBL can give that indicator for you. And finally, you might also be interested in just understanding how far away your users are from your own origin. And by forcing a miss on your CDN server and going all the way back to the origin and taking a measurement there, you can get a sense for where all your users are coming from. And you may even choose to move your origin location somewhat closer to the rest of your customers. And that would optimize the cache miss, right? So that even in a cache miss, it's not quite as impacting. Taking a little deeper look on that object size. So as I mentioned, if we look at a 1K object compared to a 100K object, a 1K object, when we make a request, we might see 0 or 1 round trips for a DNS lookup. We'll see 1 round trip between the client and the edge location to establish a TCP connection, and then just 1 round trip to make an object request and get that data back. If we use a larger object, we increase the number of round trips between the client and the edge location to download the object. Now what that does is it gives you more of an opportunity to, I guess, be exposed to packet loss. And getting that measurement can help you zero in on potential network congestion from certain viewer networks. As I mentioned, with cache busting techniques, we can isolate specific components of the system and test all sorts of parts of things that might be going on in our infrastructure. So looking at various components, DNS lookup is, if we're talking about DNS lookups with CDNs in particular, there's some trickiness there, and if you're interested in talking more about it, you can come and ask me questions. But for now, I just say let DNS lookup be as it is and focus on some of the other areas. For TCP connections, as I said, this TCP connect is what will give us the best indicator of the latency distance between the client and the edge location. And web browsers want to reuse as many connections as possible. In fact, some web browsers I've observed, on the first connection, they'll go ahead and create 4 connections to whatever server's there, and then it's going to try to reuse those connections for subsequent object requests. What's great for browser for real user experience, but if we want to measure how far away our actual viewer is from the edge location, we've got to stop that. The way you do that is forcing the browser to create a new connection. And you simply do that by making a request to a different domain name than has already been used in previous requests. Does that make sense? Yeah, so in the example there, we would just use a test domain solely for making those measurements and ensure we're not loading up any other images or objects on our web page with that domain. If we wanted to eliminate or take a measurement after the connection had already been established, we can actually prime that connection just by doing the opposite, right? We use the same domain name and just make 2 subsequent requests. We make 1 request to establish the connection and throw away the measurement result and take the measurement result on the second request. That would give you a measurement after the connection had been established. When it comes to evaluating the performance of your edge cache, it might, in order to kind of have some good scientific data, you might want to ensure and guarantee that you're getting a hit from that client to whatever edge location that's going to. That's easy enough to do. You just make 2 concurrent requests for the same object. That first call should, in all cases, load that up in the edge location. The second call will result in a hit on your edge location side. Something you should also consider, if what we're really after is understanding exactly what kind of performance our customers are seeing, you might choose to do nothing at all. Just request the object, the same object that your real users are requesting. And with that data, you know how hot or cold the cache is based on the real world usage that your customers are driving, right? Or you might choose to bust the cache in the CDN, and you would do that if you want to get that measurement from your client location all the way back to the origin. And then when it comes to client cache, don't forget it. I don't think there's really any scenario where you would care to know the performance between the JavaScript in your local and the customer's browser cache. So just don't forget to bust through it. And the most common way to do that is by appending a query string unique for each request. All right, so if we put it all together, my recommendation is don't prime the edge cache. Try to get a view of what your viewers are actually seeing. So get your cache hits and your cache misses in more of a natural way. Do remember to use a fresh TCP connection. So make sure you're using a unique domain name for your test requests. Use a 100K object to get a good sample of that LBL so you can see the quality of the network between your client and that edge location. Don't forget to bust the client cache. We don't care about the performance on the local machine. We want to see the network performance. And absolutely use the diagnostics navigation timing API wherever possible, especially in this mode. That's going to give you really detailed breakdown information on your DNS versus your TCP versus your first byte latency and your last byte latency. And finally, this one, if you're going to use real user measurement and working with a CDN, please use a request ID. If you send this request ID through CloudFront, we record it in our logs. And if you ever come to us and say, I've got a question about this, I'm seeing some odd behavior or odd performance, we can use this request ID and grab through our logs and find out exactly what was happening on the server side and marry that up with all of the other rich server-side telemetry data that we collect. So please do that. All right, now we've got our measurement collection methodology. We've designed some good tests. We're getting gobs and gobs and gobs of data back. Well, if we just aggregate that all together and look at it, it might not tell us much. Analysis is all about splitting up that data, building good graphs, and giving a lot of visibility into any issue that may be going on. So really, really good analysis or good graphs will make it very obvious when something is going amiss with your viewer experience. And it should also give you the data, the diagnostic data, to zero in very quickly on exactly what's driving that particular issue. I've got a few examples I'll walk through that are just based on things that I know that our customers are doing and things that we do within CloudFront ourselves. This isn't the definitive list. Think of this more as a way to start your own thinking about how you might segment your metrics. This is going to be very specific to your service and specific to your customers. But just so we know what we're talking about, here's a really quick example. Geographic segmentation is something we do almost all the time. This is some CloudFront requests, like number of requests for a particular customer's CloudFront distribution. It's a global all-up view from all of the edge locations. That's what it looks like. If we break that down very simply, just at a very high level across 3 different regions, you can see very different patterns emerge, right? We start to see the peaks and the troughs, and look over there in Asia. There's actually a step down in usage from Asia, a big step, right? That wasn't even visible in the global view. Now this stuff, whenever we see a signal like that, oftentimes it may be mapped to a big internet event, something that may not be in our control. For example, when the earthquake hit and severed some trans-Pacific links, there were big sections of the internet that just couldn't get online anymore, and we saw some drop-off in usage. So this kind of graph can help us quickly identify whether or not we're dealing with one of those events, or if there's something wrong with our system that we need to drill into. Client and device segmentation is also particularly useful, especially if you have customers that are using mobile devices and laptops. That's a great way to look at your data. Also, earlier this year, we had a customer that created a customer support ticket for us. They notified us of some poor performance that they were experiencing. We dug into the issue and found out that they had a higher than normal amount of cache misses. And actually, for no good reason. They had plenty of volume. The caches should have been hot. So we took another look at the data and segmented it out by client device, and we found that there was one particular client that was the driver for almost all of those cache misses. And it turned out there was one new set-top box that was just getting released out there, and it had some funky behavior when making HTTP requests, and the result was it ended up resulting in a cache miss. So because we got to root cause on that, we were able to develop a workaround and deploy it to production and resolve that issue for our customers. For those of you that are using a multi-CDN solution, I would encourage you to look at your performance data by CDN, so you know how each of them are performing for your own users, right? And this is an example that comes straight from Amazon retail site. This is actually real data. They're using 3 CDNs today. And you can see CloudFront at the bottom there doing very well, yeah? If anything changes in this, it's a way, you'll know who you need to escalate to. If any one of these CDNs suddenly became less performant, you can create a support ticket and say, hey, I'm using 3 CDNs. 2 of them are working just fine, you're not, what's going on? It also gives you the opportunity to say, I'm going to shift more of my traffic over to those CDNs that are performing best for my customers. Another segmentation scheme that's particularly important when we're dealing with global network apps is looking at your data by viewer network. I mean, one of the common drivers of poor performance actually ends up being the client networks themselves, the internet service providers. So internet service providers are managing their own network capacity just like any of us are measuring our own network service capacity. And at times, it can become overloaded. And when that happens, packet loss starts occurring, and customers on these specific internet service provider networks experience longer download times as a result of that packet loss. So viewer network segmentation allows you to zero in on that and determine whether or not a network congestion is causing poor viewer experience. The problem is that as of today, there are more than 42,000 different client networks on the internet, and 42,000 lines on a graph is more than I could ever make sense of, and you can't really see any patterns. In cases like that, my team likes to use top talker lists or worst offender lists is what we often call it. So we'll take that same metric along those dimensions. So in this case, we're tracking all 42,000 client networks. But instead of trying to plot all those lines, we just sort them by the worst performing, the slowest load time. And we might have top 10 or top 20. And at that point, that is something that we can graph and trend. So we can keep an eye on those top 20 worst offenders. And if anything changes, we can see that pattern. In fact, we might see that at a certain time of day, between 1 and 2, this particular network is having a problem. That's a real key indicator that they're having some congestion issues at peak times. We have another customer, PBS, who streams video through CloudFront. They take CloudFront access logs and process them and aggregate by an object level. So they're looking at their video performance. And specifically, when they do this list, they've been able to identify times when a particular file wasn't encoded correctly. And this technique allowed them to get to root cause, identify the files that were misbehaving, retranscode them, and upload them back up into the system. So that's the high-level conceptual stuff. In summation, the experience your viewers see on your infrastructure is very unique to your service. It's unique to your customers. And the best way that I know how to understand what's going on is to instrument your service and your clients with real user measurement. And when you get that data back, coming up with great segmentation techniques allow you to detect problems in your viewer experience. And diagnostic information allows you to get to root cause quickly and ultimately build a better experience for your viewers. All right, with that, I'm going to bring Jeff up here, and he's going to take you through MapBox and how they applied these techniques to improving their viewer experience.
Thanks, Nate. And I'm really happy to be here, and I'm glad that AWS has invited me to talk. One of the cool things about this conference so far for me has been the ability to talk with people like Nate and his colleagues and get their perspective on like how we use and abuse their service, but also talk to other folks like me, work at companies that use AWS about, you know, are we alone in how we use AWS, right? Like, do other people do what we do? So I hope by like sharing what my company does, you know, give you a little perspective on how we're using it and sort of maybe validate what you've experienced or give you different ideas. So my name is Jeff Miklas. I work at a company called MapBox. We're a small bootstrap sort of startup. We've been around for a couple years out of Washington, D.C. And we help people make maps online. So we have a service called MapBox, right? And it lets you design maps in the cloud and publish them. We're basically a publishing platform for maps. So if you have a website, and I know a lot of you do, you'd be interested in maps, I could talk to you all day about like our service, how it works, and try and talk you into it. What I'd like to really talk about today is sort of give you enough overview of MapBox so that you know sort of what we do and get an idea of our sort of platform in a way to understand and maybe how it relates to you. But I won't go much more into it than that. So right. MapBox's platform. Like I said, we have a platform hosted on AWS, and we do a whole bunch of things that let you publish maps. We have sort of a bunch of tools. So we let you take maps of the world, like street level data, color it so it matches your palette, make sort of subtle changes to it so it really works for your application. We have terrain data. We have retina labels, so like if people are looking at it on iPads and stuff, it's like the correct size labels. We let you upload your own data to our hosting environment and combine that with various layers in a dynamic way, overlay that on top of street data. And we also have like a markers API so that if you want to put dots, do the red dot fever thing on your own maps, you can go ahead and do that in our stack. And then we provide two APIs, we provide an HTTP interface, but also two sort of SDKs, one just for general web use and one for iOS. So this is basically the data we're talking about working with as MapBox. This is a basic view of our sort of world map. Our data is based on OpenStreetMap. So basically what we do is we take OpenStreetMap, which I'm sure most of you have heard of. It's sort of referred to as the Wikipedia of maps. It's a crowdsourced project where anybody can come in and help contribute to a world map. It's an absolutely great project. The maps they sometimes produce as a project themselves aren't that great looking. And so one of the value adds we add is making them really great looking. So a whole map of the world looks something like this. OpenStreetMap has really great street level data around the world, competitive with commercial providers, in some cases a little better, some cases a little worse, but absolutely competitive with them. So you can do great images of places like Amsterdam like this. And like I said, this is like global coverage. So the other part of what MapBox does is that we have an open source desktop suite called TileMill. I'm only mentioning this so you guys have an understanding of how everything works together. This is something you can download. It's free. It's on GitHub and all that. And it lets you author really great looking maps on your desktop. And it's actually what we use to make all of our maps. So people can download this application, plug it into their Esri database or Postgres or just a CSV file. It makes it really easy to take custom data that they've got, create something that looks nice, in this case just some bubbles they're going to overlay on a map later on, and in a single push of a button, push that up to our application on AWS. So at the end of the day, they'll push it up. They can, this say could be the background they're going to overlay those dots on. They can make the background look nice, make it grayed out like this, combine it with their stuff, do whatever they need to do for their application. Okay, so a few more pictures of maps, and then we'll move on. So this is the kind of data we have for places like Hawaii, right? Nice looking maps that we're really proud of. For people that like enjoy looking at maps, we have like slide decks of this stuff. So right, really great terrain data. You can do nice things like desaturate your maps, localize labels, all that kind of nice stuff. Make these sort of like classic like Tijuana at night. It's very dangerous. Kinds of maps of the world, right? So, but for our use case, right, and for what we're interested in today, it's really a matter of when I'm making decisions about a CDN and how I need my system to perform, because I'm expected to be competitive with people like Bing, with people like Google, like what is this we're talking about? So the way all these sort of online Slippy maps work is basically like this, right? And you guys probably all know this. There's individual image tiles, 256 by 256 pixels, either PNGs or JPEGs. And there's a little bit of JavaScript in your application or a little bit of Objective-C on your iPhone or whatever that stitches these guys all together, right? So the fundamental interface that we have with our clients is basically these, right? And this is sort of the main interface I have with my clients. It's an image they're going to get looks like that. Those are a few of the headers on a nice cache hit from CloudFront. This is like the interface we have. So there's really one interesting thing to point out here, maybe two, but those are some of the cache headers we use, and I'll talk a little bit more about those later, but in particular things like last modified times and e-tags. So MapBox, like everybody wants to hit scale. Like we operate at scale, we like to say, right? So for us, I want to talk a little bit about what that means to give you a sense of what kind of problems we run into. And sort of the dimensions of scale that we are concerned about. So a popular map on our service will do 50 million tiles a day, 50 million HTTP requests for those 256 by 256 images. So that's going to be around 580, maybe a little more, a little less requests a second. Right now, in peak of the day, it's going to be maybe almost twice that. Middle of the night, maybe a lot less than that. So we need to have that sort of range of being able to deal with that. And right, we don't have just like one or two of these guys. We have like thousands of maps. Not nearly all of them are, say, really popular, but we have thousands of them and need to be able to deal with this kind of volume from a lot of places. So this is actually a pretty terrible graph, but I think it illustrates my point on the kind of problems that we're dealing with our service. So the scale on the bottom is the number of maps per an account. On the left-hand side is the number of requests being done. The actual values don't really matter that much. It's a normal linear scale here, and the guys are stacked up. So you can see that the people who have one or two or three maps, I guess 2 or 3 maps, do a lot of traffic, right? These are people like maybe Foursquare, who they have like a normal map, a retina map, and maybe like a mobile map. And they're doing a lot of traffic on these very focused maps. They're sort of a traditional use case. And then way the heck out, near like 70 or 80 maps, there's people that have a lot of maps, a lot of data, and while it doesn't look like much compared to the Foursquares of the world, it actually is a significant amount of traffic that they're doing across 80-some different resources that are entire maps of the world, right? So scale we have, per customer, they can do a lot of stuff. We can have people that have a lot of data. And then there's another problem that's actually the real problem for us, and the compounding one, which is that the world is big, right? It's not that we have like a front page and a couple things people can interact with, and every client can have their own one. We have to worry about per user, per whatever. No, we have a whole world, and we're rendering it so you can zoom into any spot of the world at the street level in a way that's relevant to you standing on the street. So this is billions and billions of tiles, right? Billions and billions of images we have to worry about being able to serve out that are all valid requests at basically any time. The other interesting thing about our service is that people have sort of adopted us, and we're really happy about it, as sort of a utility, right? So that if you go to Foursquare, right on the front page is a map, and it's our map. If our map goes away, Foursquare's homepage is blank. It's bad news for them. Other people like USA Today for their weather. Weather Decision Technologies is another client. They use us for TV maps, so that on TV when you see someone waving in front of a map, that could be ours. Another interesting use case that's sort of a critical utility is for airplane pilots. They download maps just before they leave onto, I think they're like iPads, and they use those for navigation in flight. Pretty cool stuff, but it means we're considered sort of a utility provider. So specifically how we've used AWS. We've been on AWS from the start. We're real big fans of benchmarking. We've tried just about every instance type in lots of different configurations. We know like what our sweet spot is on AWS, and it's been something that's sort of bred into like how we use the cloud in general. We change things, we measure, rinse and repeat over and over again for nearly every change we make. So because we started on AWS, we used CloudFront from the very beginning. At a point in time, we got some business pressure to switch. So we're like, great, let's make a list. So let's take a look at everybody and talk about, how do we use this and should we switch? So first thing we did, what is important to us, right? Because before we can evaluate based on like the features, we need to know actually what the features are that are most important to us. So we came up with this list. Speed, obviously very, very important to everyone. Not the only thing though, right? The cost, particularly like setup fees, minimums, this kind of stuff, was something we really wanted to make sure that we had under control. Log delivery, this one's sometimes surprising. We bill based on how much of our service you use. If we don't get logs in a predictable, reliable way, in a format we can quickly work with, we're in serious trouble. Cache purging, pretty obvious. If you put something out there that's a mistake, you need to be able to get it back. And actually the quality of being able to reach out to somebody and get some support for particular issues. So these were the things, the sort of top 5 things we were concerned about. And these are the people we basically evaluated in alphabetical order. I'm sure if anyone else has done CDN evaluation, you have a similar list floating around somewhere. So we looked at where our traffic is coming from. So we were not sure before we did this exercise, like, where is the biggest users of our system? We just had a bunch of nodes in, the Virginia region, and they sort of worked for everything. So we downloaded our CloudFront logs, and they all have little codes that are pretty much line up with airport codes, made this nice map. So it's pretty obvious that most of our customers are coming from the US. And so as we evaluate speed, the US is where we primarily want to be focused. We want to make sure we pay attention to other parts of the world, particularly like Europe. But for the most part, we had this was a few months back, a US customer base. So this is a start where things got tricky for us. And actually, when I started talking to Nate about this presentation, where I started realizing some better things we could do. Our objects are almost exclusively images, right? So we don't serve a lot of JavaScript for people to use on their website that we can sort of instrument, right? We just have images. They request it over HTTP. That's our interaction with them. So it's very difficult for us at this point in time to figure out what existing real users are doing. And this is something that, as I worked on this presentation and talked to Nate about how CloudFront views things, I realized like we should start sneaking instrumentation into things. But it's not something we've gotten done to this point in time, although it's definitely on the agenda for the future. So we looked at using external monitoring tools, and we were particularly interested in ones that could model a whole page load and would load a bunch of tiles to get us as close to the experience of a user on our system as possible. So there's a bunch of different third parties that do this kind of stuff, as Nate mentioned. We picked one that had a lot of monitoring stations, 64, all over the world. And we set up 2 identical stacks, not production stacks, dedicated just for this. We ran our tests simultaneously on them, so if there's anything that happened in how the network's traffic is routed or DNS changes or whatever, they would all be covered identically. Put up the same map, same max age on it, and ran these tests for 24 hours. So I feel like that was a pretty fair test of how this is going to perform. So as objects get into cache and expire from cache, they'll be happening at approximately the same time for both of these stacks on each of the CDNs we were evaluating. And then, of course, we had some actual people. We have a pretty distributed team. We have some people in South America, a few people in Europe. And so we asked them, hey, open up Chrome, tell us what you're seeing for individual tiles in terms of fresh hits, misses, and then full page loads. So to collect that information, make sure it lines up with what our external monitoring system is telling us is happening. Not as precise as being able to actually get telemetry information from all the clients we've got, but a little bit of a stopgap that we could use. So stripped of their numbers, because they were very, very close, this is basically what we found, right? On a global basis, sort of globally averaged, this market is very competitive, right? CDNs perform very, very well all over the place, and the difference is a handful of milliseconds. In the US, when we benchmark against our stack, we found CloudFront performed a bit better. There could be reasons for this, but we were happy just knowing that it did. And it also sort of validated what we had seen before. So CloudFront for us was faster. The cost, as there's been a lot of talk about how Amazon operates generally, the cost was lower. We were very happy with log delivery. We'd already built a billing system around it. We didn't have to set up an FTP server that would somehow suck those logs over to S3 and deal with how things were broken down. Cache purging we're completely satisfied with. We sort of evaluated gold support versus the various support channels we had with other systems. And we're pretty happy with the kind of response we got and the availability of developers with Amazon. So great. We're on a good CDN. Perfect. Wonderful. Yes. Awesome. Right. So we wanted to do a little bit more, right? Because you actually can't stop there. There's 2 things we wanted to look at doing. Doing less and getting closer. So doing less. The idea here is the less your service has to do, the faster it's going to be. So like I said earlier, doing things with like proper if modified headers, this is absolutely critical, right? Nate walked through earlier how a CDN is going to fetch objects. If a CDN has an expired item and it hasn't trashed it, it's going to ask you, before it trashes it completely, can I reuse this? If you can say, yeah, use that, that is a much, much, much smaller exchange between those two servers, and it prevents your server from doing hardly any work at all except checking metadata. And you can move on real quick and serve those a lot faster. So of course, this requires you to have already done some work, right? You need the ability to check for metadata before building an object. And this is, often viewed as something that's a little bit too hard. But it's totally worth the work, right? And what we found is that put into place, we do about 70% 304s, right? That's an awesome number. It means that for those requests, we barely do anything. We're able to deliver those requests hugely faster because all we're doing is checking headers against a simple metadata table, right? This is awesome. So I can do over 4,500 requests a second for 304s and much, much less with 200s. Similarly, the response time on 304s is really fast. We're talking in the order of dozens of milliseconds versus me loading objects from remote sources, compositing them, and pushing them back out. Second thing is getting closer. Even electrons take time to cross an ocean. And if you're closer, your CDN doesn't have to go as far and misses. So this is a similar graph, or the same picture we looked at earlier of where our traffic comes from, grouped into sort of AWS availability zones. This is what it looks like, right? The US East region is the majority of our traffic. Europe comes second, right? So we're like, great, if we want to try and make things faster, let's go to Europe. Let's see what that does for us. So we put another cluster in Europe. In AWS's Ireland region, we have master-master replication between the two. There's a variety of DNS options you can use to split your traffic. We're using an Anycast solution right now. And of course, getting closer, if you've done these sort of things in the past, if you've used CloudFormation, if you have configuration management, if you've got automated deploys, this is a lot easier. Right, so the traffic splits nice and clean once we get this up and running. So there's US traffic on top, European traffic on the bottom. And this is the drop-off in actually latency from a full page load, right? So you can see we launched on the 23rd of August, and latency from a test run out of the Amazon data center goes from almost a second and a half to like 300 milliseconds, 250 milliseconds, right? And that's just moving the origin, not changing any of the technology behind it, right? It's totally awesome for our users in Europe. Their page loads just got like 3 or 6 times faster, right? So these sorts of things behind a CDN that's already fast, for us were huge improvements, right? The if modified since we can serve those 10 times faster. It's crazy. Granted, the cache has to be sort of populated already, but for a user that's getting a resource that's used a bit, it's huge. And then proximity, of course, 6 times faster is just awesome. So before I walk off here, if you fell asleep, the 3 things that we found to be useful is knowing what matters, measuring them as much as possible, and pulling together this talk, I also learned that I did not keep track of my measurements nearly as well as I should have. There's measurements that I took that were really valuable, and I spent a lot of time on that are lost to the winds of time. So keep track of what you've done in the past. And also being a good upstream to your CDN is actually where we've seen that we've been able to make the most improvements for our users.
Thanks, Jeff. All right, so we are a little bit over time. I'm going to stick around for questions if you have any, and Jeff will be here too. We have some papers that might be interesting to you. It's a performance comparison showing CloudFront's performance compared to some other CDNs, and also has more data that I showed, that Amazon.com retail data and CloudFront's usage. Thank you.